So now the first three, Na, Mg, and Al, they have metallic bonds. Okay, so just your O-level stuff. What was metallic bonds? Metallic bonds was you've got a lattice of metal lines. So you've got this lattice of metal lines in a sea of free moving electrons. So here's your lattice. Let me arrange them right. And there's going to be a sea of free moving electrons that would be completely delocalized. So metals, they like to lose electrons. So I'm talking about sodium metal over here. So sodium's metallic lattice would look like this. It's positive ions in a sea of free moving electrons. Sodium likes to lose electrons. It's not a very electronegative element. So it loses those electrons very easily, and those electrons are just moving freely. So the way you're going to describe this is that it's a giant metallic lattice. Okay, remember, this is your O-level stuff. So it's a giant metallic lattice. And it's a regular arrangement of positive metal ions in a sea of free moving ions. So regular arrangement of positive metal ions in a sea of delocalized electrons. So that is sodium. And then you have magnesium. Magnesium is also going to be a metallic lattice. The only difference between sodium and magnesium would be it's going to be a similar metallic lattice. Let me just copy this. So it's going to be a very similar metallic lattice, but there's going to be this very tiny difference between sodium and magnesium. Magnesium is in group 2. So if I draw the lattice for magnesium, that's sodium. This one is Mg. So the only difference between them is that magnesium is going to have a charge of +2. Because it's in group 2, and it's going to have more delocalized electrons because Mg loses 2 electrons, right? And the other thing is that it's going to be slightly smaller as well. You can remember across the period what happens, that the size of the ion decreases or the atom decreases because magnesium has more protons. So it attracts those electrons more strongly. So that is what the metallic lattice of magnesium would look like. TK, clear? Is this clear?
Yes, sir.
And then you have aluminium. So the reason I'm drawing all of them is because you would have to explain why the melting points are increasing. Magnesium has an even higher melting point. And then the last one is aluminium. So aluminium has an even higher melting point compared to the other two. So in aluminium's case, aluminium will have a charge of +3 because it's obviously in group 3. So it loses 3 electrons. So all of them will have a charge of +3. And it's going to have even more delocalized electrons. There's going to be a lot more delocalized electrons in aluminium. So plenty of delocalized electrons. And it's going to be even smaller. So it's going to be even smaller than the other two. The ions would be even more tightly packed. So the trend, why are the melting points increasing? So what happens when you go from sodium to magnesium to aluminium, when you go up the group? I mean, across the period from Na to Mg to Al. What's happening is the metallic bond becoming stronger or weaker? What's your understanding?
Stronger.
Stronger
Because you have more protons.
ठीक है, क्योंकि what is a metallic bond? It's the attraction. It's the attraction between the positive ions and the delocalized electrons. Like this positive ion over here, it's going to attract the delocalized electrons. The electrons will attract the positive ions. They're all attracting each other. So the greater the charge and the greater the number of electrons, the greater would be the attraction. In sodium's case, the attraction is going to be a lot lesser. +1 is going to attract the electron over here. The electron will attract the other ion. So because there are fewer electrons and there's a lot less positive charge, so the attraction is going to be lesser. So one thing that happens when you move from Na to Mg to Al, and that is that the charge density increases. So that is one. So charge density, it increases. What that means is that you've got, one second. So what that means is charge density increases. You've got more charge on a smaller ion. So that is one, charge density increases. And the second point is, just a second. Yes, charge increases and atomic radius decreases. Well, you've got a smaller ion. Okay, Zoha, is that clear? And the second thing is you've got more delocalized electrons. So there's obviously going to be stronger metallic bonds. So the metallic bond strength is going to also. So what happens is because of the two factors, the melting points increase. Stronger metallic bonds are formed. So you get a lot stronger metallic bonds. अब इसमें एक चीज है कि ये मुझे बताओ कि अच्छा there's one other question. अच्छा पता नहीं ये किससे लाइन लगाई आप लोगों ने लगाई है? Just a second, annotate. ठीक है. अच्छा now ये पहला point तो clear है ना सारों को कि why is the metallic bond and the melting points increasing? Is that clear to everyone?
Yes.
अच्छा, so the melting points are increasing. Now the other point is, अब ये मुझे कोई बताए कि why is there a bigger increase in the melting points from Na to Mg and a much smaller increase when you go from Mg to Al? Like there's a lot bigger increase when you move from Na to Mg. इसका मैं खुद ही explain कर देता हूँ. What is happening to the metallic bond strength? When you go from Na to Mg, right? So what happens is that the charge and the delocalized electrons, they double. Like they're doubling. I mean, it goes from +1 to +2. And the number of delocalized electrons, Na was losing 1 electron and Mg is losing 2 electrons. So the number of electrons and the charge on the ion, it doubles. Is that clear? But so that is why there's a big jump when you go from Na to Mg. The metallic bond strength almost doubles. But when you go from Mg to Al, it doesn't really double. Mg और Al में ना फर्क कम है, ठीक है? Mg is +2, Na is +3. So that means it only increases 1.5 times, right? Okay, the charges of Al and Mg, it's not doubling, it's +2, this is +3. So the increase is just 50% or 1.5 times. And the number of electrons, 2 electrons were lost. Now, in this case, there are 3 electrons. So there's a lot less difference between these two and a lot bigger difference between, क्योंकि यहाँ पे double हो रहा है, वहाँ पे it's only increasing 1.5 times. So which is why Mg and Al have a lot similar melting point compared to Na and Mg. मतलब वो देख भी लो Mg और Al का melting point. If I just Google it, you don't have to remember this. अगर magnesium melting point, if you just Google that, that's 650. Aluminium would be very similar. तो 650 से बस 660 तो बहुत थोड़ा फर्क पड़ा है, जबकि Na का melting point that's very low, that's less than 100, 97 है. ठीक है, तो ये चीज भी याद रखनी है कि इन दोनों का, तो they're going to ask you this question कि why are Mg and Al so similar, because उनके जो चार्ज में इतना ज्यादा फर्क नहीं है, it's not doubling, and the number of delocalized electrons, that's also not increasing by a big margin. Whereas in the case of Na, the charge and the number of delocalized electrons is a lot lesser compared to the other two. हाँ Zoha, नहीं, what's your question, Zoha? Why is the melting point higher? But I'm assuming that's your question. That, what I mean by that is कि इन दोनों के melting points में ना, the difference is huge. Like Na has a lot lesser melting point compared to the other two. So the difference is that this has a charge of +1. So aluminium has a charge of +3. So that's 3 times greater, right? So that means the force of attraction is going to be 3 times more in Al. Or Mg का क्या charge है? It's +2. So compared to Na, the force of attraction is going to be 2 times more, right? Double or triple का फर्क आ रहा है. लेकिन what about these two are very similar. इन दोनों के बीच में it's not doubling. It's if this has a charge of +2, the other one has a charge of +3. So what is the difference between +2 to +3? That's only a difference of 1.5 times, right? So in दोनों lattices के अंदर, the difference in the charge and the difference in the number of electrons is not that much. So is this point clear compared to Na? नहीं, चार्ज का तो डिफरेंस 1 है, लेकिन वो देखो ना कि लेट मी एक्सप्लेन दिस. मुझे टाइम्स बताओ कि यहाँ पे चार्ज क्या है? +1 है, और Al का चार्ज क्या है? इट्स +3, राइट? तो मतलब चार्ज में कितने का डिफरेंस आया है when you move from, like if you compare Na and Al? That's 3 times more, right? So is that clear? So Al is going to be having a lot higher melting point compared to Na, because there's a huge difference in charge. So the force of attraction is going to be a lot stronger. But on the other hand, अगर आप Al को compare करो ना इसके साथ, magnesium के साथ, तो मुझे तो कि इन दोनों में चार्ज का डिफरेंस कितना है? The only, I mean, this is +3, this is +2. तो कितने टाइम्स का फर्क है? That's only a difference of 1.5 times, right? तो इसका मतलब है इन दोनों के बीच में there's a lot more. अच्छा, so that basically means these two lattices strength wise are a lot similar compared to this one. This one is a very weak lattice. ठीक है, ये सारों को क्लियर है?
Yes, sir.
ठीक है, तो मेन जो चीज याद रखनी है वो ये याद रखनी है कि the strength of the metallic lattice increases when you move towards aluminium, and these two are very similar. So their strength is, I mean, the melting points are kind of close together, whereas Na is a lot weaker compared to the other two. ये दो factors है, ठीक है. Now moving on, the next one is silicon. What's happening with silicon? Now silicon is a giant covalent structure. It's a macromolecular structure. तो उसका अगर question है ना कि why is silicon is like diamond. Silicon has a giant covalent structure, exactly like diamond. It's going to have it's going to have a tetrahedral structure. And each silicon atom will be bonded to 4 other silicon atoms. And then they would be bonded to 4 other silicon atoms. So it's going to be a tetrahedral structure, and it will just continue endlessly. So silicon, obviously, because it's like diamond, it's one of the strongest structures. So the melting point it's going to peak at silicon. So silicon is going to have a lot higher melting point. Or uski reason, if they ask you in this paper, so you're going to mention the giant covalent structure. So that is the reason why the melting points are high. So you need large amounts of energy needed to break many covalent bonds. So that's needed to break the large number of covalent bonds. Exactly the same reasoning as diamond. I said, then you have the next thing is the last 4. जो end वाले हैं. ठीक है, what's happening to their melting points? Like their melting points are really low. And the reason is they all have simple molecular lattices. Okay. ये कौन है? ये आप लोग शेयर कर रहे हो लिंक?
नो सर, कोई लड़की थी मे बी.
तो आप लोगों ने शेयर किया ना लिंक?
She just left it. She left the group.
हाँ, लेकिन आप लोगों में
हमने नहीं किया.
हमने हमारी क्लास में से नहीं है ये जो भी है.
अच्छा, अब फिर मैं नहीं तो लिंक किस तरह पहुंचे वहां तक?
Sir, we don't know.
सर सिर्फ जो आपने ग्रुप में शेयर किया, that's it, इसके अलावा नहीं.
हाँ?
मेरे सामने लिखा था कि she was the host. आप भी होस्ट हो, वो भी होस्ट थी.
ये कैसे हो सकता है? नहीं, 2 होस्ट किस तरह हो सकते हैं? अच्छा, ये कौन है? नूर आमिर कौन है अब? अच्छा, एक सेकंड.
ये क्लास की है.
नहीं, ये भी कोई और निकल आया फिर. और माशाल्लाह समीर, ये पहले इसने ज्वाइन किया था पहले, माशाल्लाह ने. ये बल्कि एक काम कर. हाँ?
She left the class. She left the class. You can continue.
अच्छा, चलो ठीक है, मैं कंटिन्यू कर रहा हूँ. बस एक काम करना कि अब मैं कल से ना वो उधर मैसेज करना है पहले व्हाट्सएप पे, कि अगर वेटिंग रूम में होगे ना, व्हाट्सएप पे मैसेज करना है, वहां से फिर मैं ऐड करूंगा कि हम वेटिंग रूम में बैठे हुए हैं, अपना नाम लिख के. ठीक है?
ओके.
अच्छा चलो, ये कहाँ पे थे हम? सिंपल मॉलिक्यूलर. ठीक है, सिंपल मॉलिक्यूलर में सिंपल मॉलिक्यूल्स होते हैं, छोटे छोटे. ठीक है, तो ये जो लास्ट 4 है ना, दे ऑल स्मॉल टाइनी मॉलिक्यूल्स. जैसा क्लोरीन है, तो मॉलिक्यूल्स में क्या होता है, व्हेन यू हैव अ सिंपल मॉलिक्यूलर लैटिस, तो उसमें इंटरमॉलिक्यूलर फोर्सेस होती हैं. तो ये जो आखिरी है ना, दे आर ऑल अच्छा, दे ऑल सिंपल मॉलिक्यूलर. और जैसा क्लोरीन का मॉलिक्यूल है, तो क्लोरीन का मॉलिक्यूल बस यहाँ पे खत्म हो जाता है और कोई बॉन्ड नहीं बनाता. तो दूसरा क्लोरीन का मॉलिक्यूल है, तो इनके बीच में आपस में कौन सी अट्रैक्टिव फोर्स होगी? व्हाट इज द अट्रैक्टिव फोर्स?
Van der Waals.
So that's going to be Van der Waals forces. So they're all going to have Van der Waals forces, and Van der Waals forces are weak. So if you have an S8 molecule, The S8 molecules are also going to have van der Waals forces. Phosphorus has P4. I mean, just like chlorine is diatomic, it's Cl2. Remember, sulfur is a S8. Phosphorus is P4. And you've got another one, which is argon. Argon is just argon. Argon is monatomic. So you have to remember the formula of the molecules. So remember the formula that phosphorus is going to be P4, and they're all going to have van der Waals forces. Which one out of the four is going to have the greatest van der Waals forces?
Sulfur?
Sulfur, क्योंकि van der Waals forces में था कि the bigger the molecule, the greater would be the van der Waals forces. So this one has a bigger molecule because there are 8 atoms in the molecule. So you got a bigger molecule. So it's going to have more van der Waals forces. So if it has more van der Waals forces, that means it's going to have a higher boiling point. So, and which one out of the 4 is going to have the least van der Waals forces out of the 4?
Cl?
नहीं, Cl से भी छोटा है, argon है.
Ar? सर Ar के बीच में कुछ भी नहीं होना चाहिए.
हाँ, तो उसके अंदर तो फिर सिर्फ मतलब उसके अंदर तो पोलैरिटी होगी कोई नहीं, van der Waals ही होंगे ना फिर. तो so this one is the smallest one, ठीक है? मतलब masses तो सारों की एक जैसी है ना. Sulfur is 32, phosphorus is 31, argon is 38, I think. Chlorine is 35.5. So the rest are kind of the same. So anyways, this is the smallest, and it's going to have the least van der Waals forces. So ये भी question आता है इनके ऊपर कि why are the boiling points varying? Like, I mean, although they are the same, तो graph के अंदर ना they're going to ask you, they're going to ask you, okay, why is sulfur having? I mean, all of them have low melting points, but why is sulfur having greater melting point? Because it has van der Waals forces, and the bigger the molecule, it increases with size. So sulfur has a bigger molecule, which is why it's going to have greater van der Waals forces, which is why the melting point is going to be higher. And argon is going to have the lowest melting point because it's a smaller molecule, and because of the smaller size, the van der Waals forces are going to be less. ठीक है, ये clear है?
Yes.
अच्छा, अब so just remember, I'm just going to go through this. The first 3 are metallic. This one is giant covalent. These are molecules. These are simple molecules, covalent molecules, because they're non-metals. Metallic, and I gave you the reasons why the melting points are increasing, because you have greater charge and there's more delocalized electrons. So the force of attraction is more, and the metallic bonds are stronger. These two are kind of similar to each other in strength wise. This one is a lot weaker. और फिर था कि silicon is giant covalent, that's why, and simple molecules, they have van der Waals forces. ठीक है? Is this clear to everyone?
Yes, sir.
Yes, sir.
अच्छा, फिर quickly electricity conduction. I mean that's self-explanatory that NaMgAl conduct electricity. Why do they conduct electricity? Because
they are metals and they have electrons.
ठीक है, because of free
Sea
moving.
of electrons.
Sea of electrons or free moving electrons or delocalized electrons, right? So that's why they conduct electricity. Silicon is a semiconductor. It's usually a non-metal. It doesn't really conduct, but you can make it into a conducting material. You make chips out of it. Okay? And the other ones are non-metals. They don't conduct at all.
Sure, how can you make silicon a conductor?
So Smritha, when you talk about conductions, right? What happens when you move across the period? What happens to the electronegativity of the atom when you move across the period?
Increases.
It increases. So which is why the left side, that's your metals, right? So metals, they like to lose electrons. So they have delocalized electrons because they lose electrons very easily. Is that clear?
Yes, sir.
But the ones on the right side, they hold on to the electrons very strongly. So which is why they're very poor conductors. because they're not going to lose their electrons that easily. Is that clear? So
Yes, sir.
तो अब silicon जो है ना, that's somewhere in the middle. So remember, middle में ना वो transition start होती है. I mean, these ones they have they're metals. In their structure, they lose electrons, so they've got a lot of delocalized electrons, which is why they're conducting electricity. Silicon is somewhere between a metal and a non-metal. It's more non-metallic compared to its metallic properties. But silicon, if you apply a certain potential or EMF on it, it will lose electrons, and there would be delocalized electrons. Is that clear? वो
Yes.
फिर राइट की तरफ जाते हो ना, तो न्यूक्लियस में you have more protons. तो फिर if you have more protons, then you hold on to the hold on to your electrons. You don't lose them. So which is why they don't conduct. They don't let the electrons to freely move around. So silicon जो है ना, वो partially under certain circumstances वो p doping or n doping होती है physics में. You can kind of make it a conducting material or a non-conducting. So you make chips out of it. तो microscopic भी नहीं, nano scale के ऊपर you can make circuits out of it. So silicon का बस याद रखो, it's a semiconductor, that's about it, and you make chips out of it. बाकी फिर कर लेंगे. The rest is just simple reactions, what happens when you react with water, so we'll just go over them in the next class. We'll probably be done with this. This is just one page. That is period 3. तो वो इसमें बस थोड़ी सी explanation थी, बाकी तो बस simple reactions and what happens when the oxides react with water. You just have to memorize. So we'll go over that in the next class. ठीक है? और ये मैं भेज रहा हूँ आपको. ये मैं भेज रहा हूँ, ये notes में भेज रहा हूँ आपको. ठीक है? वो explanations जो है ना, वो add कर देना notes में. चलें, okay. ठीक है.
Sir, stand up के marks.
वो भी मैं भेज रहा हूँ. ठीक है?
Okay, sir.
Okay, अल्लाह हाफिज.